Yeah. And so during your undergrad/graduate time, what was your favorite course that you've ever taken?
Oh,
Long time.
Or maybe if you can't pick, maybe a couple, top three.
Yeah. I guess I enjoyed automata theory. I don't know. That was a big area at the time. Now it's not so much of an area.
Sorry, atomic theory?
Automata theory.
What would that
So
be?
what is that?
Well, formal theory of machines, finite state machines, push down automata.
Oh, automata, like automated.
Yeah.
Oh, okay, that's where that. Okay.
It should be called automaton theory, like machine theory. We don't say machines theory.
Mm-hmm.
It should be automaton theory, but it's called
plural.
automata theory.
Okay, so it doesn't really make it. So back then, that was one of your, and that was what was that? What were the characteristics mainly of that course? Was it?
I guess it was logical, mathematical, not very hard.
Okay.
And that was a graduate level
That
course?
was undergraduate, I think.
Undergraduate, okay.
Undergrad. Did you ever take any, because this is a math and physics podcast, did you take any physics courses in your
I
undergrad
took 2
and
years of
graduate level?
physics.
Okay.
Okay.
And?
I didn't do anything quantum related. We did electromagnetic theory.
Mm-hmm.
I guess I like special relativity because I found it incredibly easy.
Wow.
It really is. I mean, it's just a few equations. You apply them consistently in the same way every time. It's as theory. It's so limited. It only handles fixed, constant frames of reference, constant velocity frames of reference.
Right, inertial
frames. It's a very, very, very limited setting, and within that setting, there are these equations which tell you everything.
Mm-hmm.
And so I kind of like that. That was so easy. It really is easy. I'm not making that up.
No, for sure. You can definitely derive with like very easy like situations. Just you assume the speed of light is constant in all frames, and then all the equations kind of fall out.
And even if you don't know how to derive them, you just remember them. I mean, there just are like 2 or 3, and then there are these paradoxes, these barn door paradoxes, if you're familiar with those.
Mm-hmm.
And you have to resolve those paradoxes, and the resolution is different frames see things happening in different order, and it's just very easy to do these calculations.
And so
that's one thing I remember. That is one of the easiest parts of physics was the special relativity.
And so did you start your undergrad doing physics and math, and then went into math only, and then computer science?
I got a math undergraduate. Certainly I found the advanced math courses the most difficult.
Right.
But I took 2 years of physics, and never felt I really got into that very deeply. I never did learn what Hamiltonians and Lagranges and stuff like that are.
Right. I think I'm about to get into that this year.
The classical mechanics.
Classical.
So a little more intrigued in the theory behind a lot of it rather than the, you know what I mean? Because I'm assuming the theory, science, especially these days,
physics is difficult, but that particular theory is, I think, quite simple.
Yes.
Special relativity.
Yes. Okay.